Hi there. Today we're going to be talking about an introduction to exponents. Exponents are also called powers. So powers and exponents are the same thing. We're going to start with the first example of 2 to the 6th power. So there are different parts of this expression. In this expression, the 2 is called the base, and the 6 is called the exponent or the power. So we would say this as 2 to the power of 6 or 2 to the 6th power. The base is the number that is being multiplied repeatedly. Exponents or powers are a way to show a shortcut for repeated multiplication. So in this case, the 2 is the number that's being multiplied repeatedly. The power or the exponent represents how many times the base is being multiplied by itself. So in this example, 2 to the 6th power represents 2 times 2 times 2 times 2 times 2 times 2. Repeated multiplication. 2 is being multiplied as the base 6 times because the exponent tells us it's being multiplied by itself 6 times. 2 to the 6th power does not equal 12. Notice that these are being multiplied, not added. So it is not 2 plus 2 plus 2 plus 2 plus 2 plus 2. It's being multiplied. To find the answer, I'm going to go ahead and combine each pair of 2. 2 times 2 is 4. So I have 3 pairs of 2's. So I get 4 times 4 times 4. And I continue on. So we get 2 of the 4's multiplying to get 16. And we bring down the third 4. 16 times 4 is 64. So 2 to the 6th power equals 64. Definitely not 12. One of the most important things to remember as you work with exponents is that exponents only affect what they are next to. The next few examples will help you see what that means. Here's an example where we get a different result because of what the exponent is next to. First, let's talk about the directions. Directions say to evaluate. When you see the word evaluate and you're not sure what you're supposed to do, recognize that the word value is kind of hiding in that word, evaluate. You are finding a value, a number. So when you are done with this, you should have a number as your answer. It should be totally simplified down to just a number. We are evaluating. In the first part, -5 is in parentheses, and that 4, which is the exponent, is next to the parentheses. That means it affects everything in the parentheses. The -5 is being multiplied by itself 4 times. On the second one, the power of 4 is next to the 5, and this negative is out front. This negative represents the opposite of 5 to the 4th power. This exponent only affects the 5, not the negative. So that's really kind of a subtle thing, but important. So we have a comparison to look at. We are comparing -5 in parentheses to the 4th power versus -5 to the 4th power. We've got things set up so that we can begin to evaluate and get the result and see what happens. In the first one, we have -5 being multiplied by itself 4 times. -5 times -5 gives us positive 25. And we have 2 sets of those. 25 times 25 is 625. So -5 in parentheses to the 4th power is 625. On the right side, we have the opposite of 5 times 5 times 5 times 5, which becomes the opposite of 25 times 25. Now we have the opposite of 625. The opposite of 625 is -625. So in this case, the exponent made a big difference because it was next to the parentheses here, and we got a positive answer, and it's only next to the number here, and we got a negative answer. Sometimes they end up being the same, but sometimes they don't, so you need to be careful. Let's look at a couple more examples. These set of directions say simplify. Your answer should contain exponents. So that's different than evaluate. When you evaluate, you're getting a value. In this case, they're making it very clear that when you're done, you should still have exponents. We are not evaluating. For part A, we have 3 to the 4th power being multiplied with 3 to the 3rd power. They have the same base. Let's see what happens when we write this out the long way. Remember, exponents represent repeated multiplication. So our 3 is being multiplied by itself 4 times in the first part of the expression. In the second part of the expression, the 3 is being multiplied by itself 3 times. These two parts are being multiplied together. So we're going to bring this multiplication sign down. And now you can see we have 3 being multiplied by itself 7 times. 1, 2, 3, 4, 5, 6, 7. That becomes 3 to the 7th power. And that's all the farther we're going to take it because that is simplified and our answer contains exponents. Let's look at another one. 5 to the 2nd times 5 to the 4th. They have the same base. When we write it out the long way, we'll be able to combine them. 5 to the 2nd is 5 times 5. 5 to the 4th, 5 times 5 times 5 times 5. We're multiplying those together, so let's bring down that multiplication symbol. And you can see we have 6 5s all being multiplied together. So that becomes 5 to the 6th power. You might notice there's a shortcut that we're going to be looking at soon, but for now, let's just see what happens with the next few problems. All right, in example 3, you're only being asked to simplify, but you can see when you look at the expression, there's a lot going on. We have numbers, we have variables, we have powers. This is a great example of why exponents only affect what they are next to is really important to remember. This first part of our expression, this first term, has a power of 2 sitting here, but the power of 2 only affects the n. It does not affect the m, it does not affect the 5 or the negative sign. It only affects the n. So if we were to write this out the long way, it would be 5 times m times n times n. That is being multiplied with the second term. And in the second term, there's a power of 3. The power of 3 is next to the m. It is not affecting the n, and it is not affecting the 6. It only affects what it's next to, and it's next to the m. So if we were to write this one out the long way, it would be 6 times m times m times m, and then 1n. So if you don't have a power on your variable, you can assume there's only one of them. This is m to the first power. This is n to the first power. Okay, so now we have a long string of multiplication. You can multiply in any order you want. I will recommend multiplying the numbers first. This is -5 times +6 gives us a -30. We have an m, and we have 3 m's over here. When you multiply all those m's together, that is m to the 4th power. There are 4 of them being multiplied together. And then we have our n's. 2 of them on this side, 1 over here, but it's all just multiplication. So that is n to the 3rd power. So when you're finished, your number should be in front, variables in alphabetical order, and just remember the exponents only affect what they are next to. All right, so here's another one, part B, same directions, we're going to simplify. We have 8c to the 3rd, d to the 2nd, times 8c, d to the 4th. So the power of 3 only affects the c. The power of 2 only affects the d. Nothing affects the 8. It doesn't have an exponent next to it. Same over here. This 8 does not have an exponent that we need next to it. It's a 1, but it doesn't change anything. The c also has that 1 that we don't bother to write because it doesn't change anything. And this power of 4 next to the d, so it only affects the d. Let's write it out the long way just to really see what's going on. Okay, so there is a lot going on here. And once you understand it, you won't have to write it out this way. But for now, this really helps kind of make it obvious what's happening. So we have 8 being multiplied with another 8. You might be tempted to say 8 to the second power for your first one because it is 8 times 8, and that is 8 to the second power. But because there are variables involved and it doesn't tell you specifically that you should have exponents in your answer, although some of them will, I would go ahead and multiply this out. It wouldn't be wrong to say 8 to the second power, but it's more simplified if you just say that it's 64. All right, so now we've got our C's. There are 3 of them and one more here. That's C to the 4th power. And our D's, 1, 2, 3, 4, 5, 6 of them all being multiplied together. That is D to the 6th power. So when we're all done, this simplifies down to 64 C to the 4th, D to the 6th. Taking a look at the exponents from the original to the end, you might be noticing a pattern, and that is definitely something we're going to be talking about more next.